In this video, we're going to look at activity 21. Previously, in activity 20, we investigated the resistance of an LDR. This time we're going to use a different component. We're going to use a thermistor. You can see here the circuit symbol for the thermistor, and you can see that we have two yellow terminals. When we investigate resistance, we use our multimeter on the component. We don't need to worry about the polarity. We don't need to worry about the way that we wire the component in. We need to make sure that we connect it correctly to the multimeter. So here again we have our multimeter, and you can see here we have all our various different ranges around our dial, but we're looking for this symbol here. So this is an ohm symbol, and resistance is measured in ohms. So again we have our various different scales around our dial. We have 2000 micro ohm scale, a 200 ohm scale, a 2000 ohm scale, a 20 kilo ohm scale, a 200 kilo ohm scale, a 20 mega ohm scale, and a 200 mega ohm scale. Now you can see for the vast majority of these scales, they go up in multiples of 10, and they're called decade scales. We've got 3 sockets on our multimeter. This one is COM, and we always connect a lead into COM when we're using a multimeter. This one here again, you can see written above the socket, we have volts, ohms and milliamps. So we're going to use this socket. Now, as previously in activity 20, you can see that we don't have a bank of cells, and we don't have a series circuit of components that we're introducing this into. We're testing this component solely on its own. That way we don't have any variances in the reading. We know that the resistance is purely from this component we're testing. So I'm going to put a lead into COM and connect it to this terminal. Put a lead into the volts, ohms and milliamp socket and connect it into this terminal here. Now I'm going to switch it to the 200 kilo ohm scale, and we can see already that we have a reading. So at the moment it is showing that our thermistor is giving a 6 kilo ohm reading. Now if I put my finger on the thermistor, hopefully you can see that the resistance is dropping. If I warm my hands up a little bit and try again. Okay, so you can see that the heat from my finger is causing the resistance to drop. And now, as that thermistor cools down, we should be able to see that the resistance increases. So here we can see that slowly our reading is going up. So just by putting my finger on this component, I've dropped it from potentially 6 kilo ohms down to 5. So we've had a 1 kilo ohm drop in resistance. Now perhaps if I put a hairdryer over that, we might see a much greater drop in resistance. So by using our multimeter, we've been able to prove how this thermistor operates. So the cooler the thermistor is, the higher the resistance. The warmer the thermistor is, the least amount of resistance. The resistance drops with heat. This component is quite often to be used in cookers and other units that rely on high temperatures. In the next activity, we're going to wire in our thermistor into a circuit.